Thanks, Pete. Good morning. Oh, come on, we can do better. Come on, good morning. Everybody say good morning. All right, all right. So you guys want to hear a funny story, right? I'll start this off. Real quick, Pete, how long do you want me to talk?
Hour.
Okay, good enough. So I'm from New Mexico. I spend a lot of time traveling throughout the country. I work with a lot of different municipalities and developers, architects, engineers. I don't remember everything from geography class in high school, especially when I come to the far northeast part of our country. Where I come from, states are giant. You don't just go into different states. And there aren't cities named the same name in state to state to state, right? So the guy that I consult for, the owner of EcoRain America, the company and the technology I'm going to talk about, he booked my flight in. For some reason, he booked me into Hartford, Connecticut, rather than Burlington, Vermont. No big deal. Rent a car, I'll see some countryside. I got into the airport yesterday, 4 o'clock, Hartford, no big deal. Lots of time, grab some dinner, life's good. I get my car, and I'm headed out of the lot, and I ask the guy, all right, I just need directions to Burlington. Oh, that's easy, you just head up 91. Cool. I said, that takes me all the way to Burlington? Right into it. It's like, man, this is amazing. Yeah, you all know where this is going, right? Well, Vermont doesn't have road signs, apparently, or self-service, right? And so as I'm driving up, I realize, wow, there's really no restaurants. Most people's lights are off. I really hope I don't hit a moose or something, right? I'm going, I'm like, man, I should really be there. I start hearing French radio stations. I gotta be getting close to Burlington. Big sign, turn a corner, welcome to Canada. Don't turn around. Oh, crap. So I drive in, Canadian Mountie, he's like, hey, welcome to Canada. So I told him the whole story, and I'm like, dude, I'm trying to get to Burlington. I don't want to go to Canada. He said, no, you're in Canada. What? Yeah. And so the ironic thing, 5 minutes before this, I was talking with my wife. She's like, oh, you should go to Canada while you're up there. And so I get turned around. I'm coming now back into the United States. I tell him the same story, and the guy kind of looks at me, and I give my rental paperwork. Everything's good until a cop comes up, talks to him. He says, hey, we need to talk to this guy. So the guy says, let me see your passport again. I'm like, oh, no. Pulls my passport. 8 cops come out, pull me out of the car, tell me leave my car in line and come inside. No way is this happening. So I come into Canada, or come into the US. I'm detained, coming back into my own country. It must have been Donald Trump's fault, somehow. I don't know, this whole immigration thing, right? Long story short, they get a huge chuckle out of it. The people who did my rental car paperwork got the license plate number wrong somehow, and so it didn't match up. They had to call Alamo, make sure everything checked out. Lo and behold, I'm still 2.5 hours away from Burlington, Vermont. So I took a trip through Vermont, really, really rural Vermont, stopped for directions 4 times, finally flagged a guy down, oncoming car. I got in his lane and just started hitting my brights. He slows down, he looks at me like I'm crazy. I said, dude, I have to get to Burlington, Vermont. Oh yeah, you're only 20 miles. And so this is my trip so far, right? So thanks very much, it's been entertaining. I will tell you that some of the things that I say to you today will probably be a little bit different than what you're used to hearing. I may offend a couple of you, and that's perfectly okay with me. I hope it's okay with you. And there's a reason for that. Before we get started, let me see a quick show of hands. Show me how many municipalities we have in here. Okay, how many engineers do we have in here? Great. How many contractors do we have in here? Great. Any architects? Forget those guys. Okay, perfect. Good enough. That helps give me an understanding of where everybody is so I can kind of tailor the presentation to fit specific needs. So you can't read any of that. A little bit about me. As Pete said, this is something that I've done for a very long time. I have a passion for water that very few people have. I don't know why. It's something that I think about a lot. Specifically stormwater, and that's what the book was written on. I wrote a book entitled How to Solve the World's Water Crisis, One Drop at a Time. And really that's what it comes down to. Regardless of where you go in the country, there's water issues, period. I've had the good fortune on working on close to 700 projects, I believe. I've worked, you name it, I've done them all. I've done master plan communities, I've done hospitals, universities, military bases, hotels, hospitals, you name it. So from a design perspective, I completely understand where the engineers are coming from. As a contractor, I was the first contractor in the US to implement rain harvesting systems in a master plan setting in the Southwest. From that, some laws were developed requiring sustainable water efforts, and that led into everything else. You engineers out there understand that I worked as a subconsultant to engineers for 5 years. So all I did is solve stormwater problems that engineers were having a hard time solving. This is not something that I just do as a day job. This is something I'm extremely passionate about. The reason that I'm so passionate about it is I have a gaggle of kids. Like, I got a bunch of them. I lose count. I think I got like 5, something like that, right? Here's my concern. There are so many problems in relation to stormwater in the US, and it's so much worse than people think. I'm worried about my kids. I'm really worried about my kids. 50 years from now, when they come to me and they say, what the heck happened? At least then I can say, you know what, guy, we did everything that we could. The problem is so many people just really aren't aware of what's really going on out in the world. So that's just a quick bio on me. I've been doing this for a long time. I love what I do. That's enough. So I'm going to cover some ground that most of you are very, very familiar with. However, I'm going to cover it in such a way that will help you understand how we got to where we are at, okay? In a natural environment, regardless of where you go in the country, there's water issues in our country. Either you have too much and it's getting contaminated, or it's contaminating fresh water sources, or you don't have enough and you have to maximize every single drop. Which one's more important? They're both equally important. Both of those factors put us in the position that we're in today. Most people, especially, you know, it's interesting to me because I work with so many different areas of the country, to come up into the Northeast because you guys don't have a shortage of water. So many places that I work, you know, you go to Las Vegas, Nevada, or Tucson, or Phoenix, or LA, and it's dismal. It's really, really scary. You guys don't have those issues. You guys have too much water. But because of that, and because of the way we have developed over the last 50 years, you guys have serious, serious contamination issues. All of these are combatable and they're overcomable. However, you have to understand, right, just as everything evolves, right, you're talking about the evolution of HDPE, and that's fantastic. Just like you said, everything evolves, right? Well, here's the problem. With the way that we've developed over the last 50 to 70 years, we've taken away the natural environment to a large extent, meaning we develop with so much hardscape. And understand that I speak to you as a developer, okay? Before I started this whole water thing, I was a developer, president of a home builders association in Santa Fe, New Mexico. I was a national director for the National Association of Home Builders. So this is all I understood, right? Well, in understanding how we develop, right, and I'm one of those guys. So when I say we, or y'all, understand I'm including myself in this group. I am part of the group that caused the problems that we are experiencing, as y'all did, you just may not know it. So here's the thing, we develop with so much hardscape, water has a hard time just seeping in where it lands. It travels down a contaminated surface, gets pulled up with more contaminated water to go ruin the good water. How does that make sense? It doesn't. When our infrastructure was developed 50 to 70 years ago, engineers did not sit down and say, man, how do we create a really bad situation 70 years from now? That's not what happened. So I don't want to convey that that's what I'm trying to say. The architects and the municipalities and the engineers that did their job 50 to 70 years ago absolutely did their jobs to the very best of their ability. The building materials and the technology that they had at the time, they did as much as they could with it. However, here's what's caused the problems that we're in. So regardless of where you go in the country, it looks just like this. You have a building, you have sidewalks raised, you have planting areas that need water, you have a contaminated driving surface. And so, can everybody still hear me if I just yell, right? You have a building, water comes off that building, hits a surface, hits a contaminated surface, and runs away. Yet, this landscape requires water, so we throw that water away and then we pump up groundwater to replace the water that we just had and ruined. How does that make sense? And this is how the entire country's developed, right? Looks just like that. You have a street with asphalt that's turned white because there's no oil left in it. All of that oil comes out during rainstorms, runs down a contaminated surface into a manhole where it's kicked out to a fresh waterway or wasted, depends on where you're at in the country. Out here, you guys push it into fresh waterways. Where I'm from, we waste it. Okay? Here's the problem. The way we have designed, right? Civil engineers, this is the way we have designed. And this is what it caused. Stormwater is the largest source of water quality damage in U.S. estuaries. Second largest for wetlands, third largest for lakes, fourth largest for river damage. Is this good water management? No. Who's responsible? Every engineer in here, every contractor, me, right? I'm including myself in this. We are responsible. Because of the way we have developed, it's caused these issues. And people say, okay, well, we gotta start designing green systems. We gotta start designing sustainable water systems. Can someone in this room give me a definition or an explanation of sustainability? Anyone want to take a stab at it? Please.
Ideally, a system whereby natural ecosystems are not damaged, but at least held steady or rather improved.
I'm so impressed. Most of the time when I ask this question, most people are too scared to answer, and when they do, they're kind of off. That was really close, okay? Sustainability defined is using a resource in such a way the resource is never damaged, okay, or runs out. So if you're running water or you're running out of water, you are not sustainable. The problem is, all of the design professionals in here, not one of you had a definition for sustainability. So how do you know what you're designing is sustainable? If you don't know what sustainability means, how is it sustainable? You don't know. That's a problem. Because if our water systems aren't sustainable, our kids are screwed. We're dealing with issues that you guys just wouldn't believe because you come from this part of the country. But the rest of the country is in really, really bad shape. Why? Because of what we did 50 to 70 years ago. Does it make sense to keep doing the same things that put us in this position? No. So why would we? It comes down to money. Always comes down to money. We have to come up with solutions for our engineers and ultimately our end clients that don't waste real estate, that cost less than what they're using right now, and have more design capability than what they're doing right now. So how do we do that? That's not an easy thing to do. Let's get into it. Real quick, I'd like to say something on purple pipe, right? Everybody here is familiar with purple pipe. If it makes sense to take raw sewage, pump it to a multi-million-dollar treatment facility to turn it into water that's just barely good enough for landscape, and then you pump it right back up to the area where the water came from originally, if that makes sense to you, why are you not using your water resources on site more intelligently? If you do things right, that's not necessary. Is that a good idea? Yes. Any extra water is a good idea. And that's the basis for my book. How do we overcome the problems that we're in right now? You pay attention to every single drop. It doesn't matter where it's coming from. You actively manage it at the point of contact, then we're on the path to sustainable. The country got into the problems because the municipalities took it upon themselves to provide a centralized approach to water management. At the time, it seemed like a really good idea. The city said, hey, we'll supply you water. Oh, and by the way, the water that comes off your site we'll deal with. Well, 25 years ago, when you built something, you could just push all that water away from the development to your neighbor. Okay, so those days are gone. Water has to be kept on site, and it has to be managed actively on site. Same thing, the centralized approach, this is where it got us. The original road design came from the Romans. We haven't changed it a whole lot. There's a typical Roman street that's above an aqueduct, which is kind of funny to me. But if you look, I mean, there's sidewalks, there's drop inlets, streets. It worked really, really well for them because they didn't have the population or the contamination issues that we do. But since I'm talking about the Romans, do you guys know what the downfall of the Romans was? There were several factors to it, but the big thing that got them, the barbarian hordes that were trying to overtake Rome, they figured out if they could take out the aqueducts, they'd get it. Rome went from a population of over 1 million to less than 30,000 in 1 year because of water. Do you guys know why the Mayan culture ended? Water. If you don't think that our water problems right now have the capability of displacing your entire life, you're very mistaken. History has proven time and time again humans can't go without water. Period. Can't change it. So it's something that we really need to start paying attention to. Because of the centralized water management, it caused all of these problems. So what's the solution? We have to start moving towards a decentralized approach, especially when it comes to stormwater management. The company that I represent, EcoRate America, we don't manufacture concrete. We don't do anything with drinking water. We don't do anything with sewer water. All we do is stormwater, and we're great at it. Okay? If you are able to manage that water as an asset versus a liability, right? For the last 50 years, if you build something, man, push all that water away because it's bad for the structure. It's bad for the structure. That's a true statement. But that water is still also valuable. So you need to understand how to manage it a little bit better. When you do that, you move away from all of these things. Out west, it's important that people use the stormwater, right? Which they're not doing. Even though they're really, really short on water, still all of the water from new sites is pushed away, and they pump groundwater up to water the stuff that they just pushed the water away from in the first place. And this is done on a national scale because as civil engineers tend to do the same things over and over and over and over. It's just the way we've always done it. Great, if that's awesome. If it serves our purpose, it doesn't. So we have to start taking a look at different ways to do things. Definition of sustainability. I'm so impressed that you almost got that. That's fantastic. Okay, so now let's get into understanding what sustainability is, right? And how do we design towards that sustainability? If you design your stormwater systems correctly, all of the problems that you're currently dealing with go away. There's just more dynamic capability in the marketplace than there used to be. I'm not picking on you. It might seem like I'm picking on you, but I'm not going to pick on you. Okay. So, understand first before we get in this, and this is an argument out west, right? We talked about putting stormwater underground and letting it infiltrate rather than using above ground retention ponds. And I've gotten into arguments with the EPA. I've gotten into arguments with engineers. So finally I put this in my presentation so I could show the EPA guys, no, really, this is something that you promote. Underground drainage or infiltration is absolutely recognized by the EPA as a best management practice. Okay? So here's the evolution. Everybody knows what a French drain is, right? Dig a hole, fill it up with rocks, water sits in the rocks till it has a chance to soak in the ground. Much like a glass filled with ice, it's full of ice, but you can still put water in it. Same concept. So this has been done for thousands of years. This is where we started off. Next, we went to, is that a laser pointer by chance? It's not.
Yes, it is.
It is? How do you activate the laser? Oh, cool. Great, thanks. Okay, so these are still culverts wrapped in geotextile with holes drilled in them. This was a better idea than this because this had more void space, therefore your hole was smaller. But the problem with this is inside that pipe is the only true void space. Yes, there is void space in the aggregate. Depending on what aggregate you use, 20 to 40%. However, with that said, that is the only true void space. So this was better than that. Enter arch chamber systems. This is better than that because, in my opinion, the plastic costs less than the steel. One of the big problems that has put us in the position that we're in right now is 50 to 70 years ago, concrete and steel were the only materials available. Concrete and steel gets eaten by earth, period. It doesn't matter. If you put a piece of metal or concrete in the ground, it's only a matter of time before it goes away. This is how we got ourselves into a $1 trillion water infrastructure problem. Boston loses 40% of its water to leaky pipes. Well, you can't dig up Boston. And it happened because of concrete and steel. Again, 50 years ago, they didn't sit down and say, let's figure out how to screw it up really bad. It was the best thing that was out there. However, now with plastics, the life expectancy and the lifespan goes way, way up. It's like burying a water bottle. If you come back 100 years from now, you can go dig that water bottle up, no sweat. So this is a better option than this. But again, there's still a tremendous amount of aggregate, right? The plastic costs less than the steel. This has a longer life expectancy. So this is usually less expensive than this. Here's where we come in. So EcoRain America, we manufacture modular boxes, okay? They are made out of recycled plastic and have a life expectancy of, it's like 500 years. What makes us very, very unique is that our systems can be designed in any shape, at just about any depth, any length, any width, and there's no gravel backfill in the middle of it. So how does this translate, right? Ultimately, it works the same as all of those systems. The thing is getting the water back into the ground. But when you're able to dig half the hole and use 90% less backfill material, you're way ahead of the game. And that's what it comes down to. On average, every site's different, but on average, we are half the size of a hole over arch chamber or culverts and require 90% less backfill. For the contractors in the room, this is a huge deal. Because as an engineer, you've never had to have flagmen watch 100 gravel trucks come in and unload, and the equipment that it takes to move that around, and everything else that goes along with it. It's a pain. It's a serious, serious pain. So if you're able to do the same thing as you did before, yet manipulate that in any shape that you want, now we're getting somewhere. This is evolution. The boxes are very lightweight. They're assembled on site. They snap together with a rubber mallet very, very quickly. And it enables you to create the system to fit the site rather than the site having to fit the system. So if you need an infiltration trench that's 2 feet wide and 8,000 feet long, cool, we can do that. You can create any shape that you want. Now let's really start thinking outside the box. Imagine if you had a development, a shopping mall. Let's talk about a shopping mall, okay? Everybody close your eyes for a second and imagine your bird looking down on a new shopping mall being built. You have a giant building, you have an ocean of parking lot with tons of drop inlets. All of those drop inlets are connected via concrete or steel pipes, right, that convey all of that water to one specific spot where you're trying to manage it. What if you got rid of the conveyance? What if there were no pipe on it whatsoever? What if under each drop inlet you had a miniature infiltration field? As small or as big as you want. The water's able to enter into the system right then. The problem with pipe is it's not permeable. It does its job, it moves water from point A to point B, but if your whole goal is to try and get the water in the ground, that pipe is impermeable. With our system, the boxes can be used as conveyance if you want to, or there can be miniature systems. You can do anything that you want. Imagine if you had one main trench and then you had tons of tributaries split off underneath the landscaped islands in a mall parking lot. Which costs more? Concrete, steel, or recycled plastic? Plastic. Which costs more? Gravel or no gravel? No gravel. And you're not limited in how you design and how you approach your stormwater management. This allows you to be extremely creative. So people will ask me, well, how do you clean the water in it and all these other things, and we'll get into that. But understand, despite the fact that that looks like a tremendous amount of plastic, it's really not. It's still 95% void, and it's H25 load rated. So now you have no holdbacks whatsoever. This is the most efficient use of space on the market, period. This was this particular job was done along the new runways at LAX, at Los Angeles International Airport. At the time, it was one of the largest infiltration systems in the country. What made our system very, very unique is they had a depth profile that they had to stick to, And that sewer line right there had to stay. They couldn't take it out. They had no room here, they had no room there. So we were able to create our system around what they already had. What other systems on the market can do this? None, unless they copied us. And if you see any other box type systems, they copied my boss. The guy that I consult for and run his company in the US for, he invented it, period. I was there 15 years ago when he was filing for it. This is how these systems go together. You lay geotextile out, stack the boxes in the middle, wrap it up in geotextile, and backfill around the edges. And that's just for structural. That's it. Again, you're able to manipulate the shape in any way that you want. This is a job that I personally did for a Naval Air Station in Jacksonville, Florida. They wanted to harvest the water. What was interesting about this, the water table was at 3 feet, and the water table was contaminated. They didn't want the water table was contaminated, and their big concern was that contaminated water getting into a fresh waterway. We were able to create a harvesting system at an overall depth of 2 feet and stored 110,000 gallons of water. No sweat. It doesn't matter to us which way the boxes are stacked. Volume is volume. If you have a volume of, say, 10,000 cubic feet, the city doesn't care what design that's in. They just want to make sure that that amount of water is being held and you're getting it into the ground. Well, you can do that in really, really creative ways. Basic components to a system. Water comes off of a surface, whether that's a building or a surface or a parking lot, goes through a pre-treatment, like a sediment filter. We manufacture these HDPE triple stage filters to remove anything from sediment to hydrocarbons. It doesn't matter. We can customize these for you. The secret to it is making sure you put as clean water in these things as possible. We get asked the question a lot, well, what if we need to flush this system out? That's really easy too. So the water comes through a pre-treatment, gets into the boxes, and sits there until it has a chance to soak in. As far as a flush mechanism is concerned, you can have one flush pipe here, one there. Flush with water, suck it out here. Everything gets stirred up and it gets sucked out. If you wanted to create one chamber that does only that and then the rest of it overfills into the rest of the system, so you're only trying to clean out sediment from one spot, that's easy too. Again, that's what makes us so cool, is there's no limited design whatsoever. You can create the system that you need to create. This was a military base I worked on. This was a perfect example of a project that previously had tons and tons of conveyance infrastructure, and we got rid of all of it. We looked at individual areas and the stormwater requirements. We used boxes to convey the water, so the water was seeping into the ground the whole time, and then we put the systems underneath the parking lots, the leftover that we needed. There was zero real estate lost to stormwater management. What a concept. The idea of above ground retention areas, it's a terrible, terrible idea. They take up real estate and they're a liability. I have yet to hear one customer come to me and say, please figure out how to put more above ground retention ponds in. It doesn't happen. But is it still happening in design? Yes. What's worth more, that land or the recycled plastic boxes? Well, the land is worth way more. How much money can you make on that real estate over the next 100 years? Now really it's worth it. Roadway design. Here's the old way. You have curb and gutter. Water runs down that curb and gutter, picks up all sorts of trash and oil, hits a drop inlet, and gets kicked out to a river or a lake, or if you're in the West, it gets wasted, right? This is how the entire country is developed, people. Imagine if you had a permeable drainage system. Water rolls off the crown and enters that system at any given point. And I don't want to get hung up on this. There's lots of ways to do that. And if you guys have specific questions, we can talk about that afterwards, but that's easy. Water rolls off the crown, enters in the system at any given point, which also means that water can exit at any given point. If you don't want water here or you want to convey it, just use an impermeable liner as a bladder. That's it. So now this is an entirely new way to understand drainage infrastructure over the way that we've been doing it forever, which makes sense. That or that. This is watering the trees, there's no trash. And it took out 90% of the contamination because it's not traveling down the roadway. This is how the country's developed. This is how it's not. This is what's led us to the problems that we're in right now. Again, at the time, they did their very best job, but it does not serve our purposes or our best interests anymore. This is another job that I personally did. City of Albuquerque, old neighborhood. Little old lady made her city councilor miserable. There was drainage issues, and she couldn't walk out to get her mail. There was always a standing puddle of water. So this city councilor says, listen, this lady's about to drive me crazy. I'm spending my entire budget to make her happy. We need help. I said, okay. So they had their on-call contractor come in and give them an estimate to install curb and gutter in this one area. The cost was $2 million. We came back and just looked at the problem spots, did our stormwater calcs, did roadside infiltration systems. The same on-call contractor installed it. The finished price was $75,000. 5% of their original estimate. You cannot convince me that the old way of doing it is better than that way. And it was like a fraction of the time. They got this done in like 3 days. It would have taken weeks the other way around. Same type of system, only this is in Qatar. We do a lot of work in the Middle East. That one particular system was like 20 miles long. But it's great because the system fit the site rather than the site having to fit the system. You have unlimited design capabilities. For those of you that are still working on LEED projects or have LEED projects coming up, we kill it when it comes to LEED. Because our product is so innovative, we can capitalize on LEED points that other people cannot, such as stormwater design, quality control, heat island effect, innovation, recycled product, on and on and on. We can provide up to 20% of the total points necessary for the entire project for LEED certification. That's unheard of. I've never heard a manufacturer's rep stand up and say, hey, we can get you more than like 2, 3, 4 points towards LEED. We can get you 20. A couple other products that we make. The boxes that we make, the reason that they're so cool in my opinion is just because it's a better use of void space. It's 95% void. Well, we started looking at ways to create void spaces for other applications, such as rooftop gardens, right? And you guys are saying, well, how do you fit one of those boxes under that? You don't. We have another product that creates a 1-inch void space and one that creates a 2-inch void space. So it's really easy to start imagining rooftop gardens. You have a liner, a 1-inch void space, a layer of geotextile, your planting material on top of that. That's it. Water travels through the medium, hits the liner, runs off. If you use the right liner, it creates a vapor barrier. It's guaranteed that that building will never see water intrusion. And that's a really simple way to design this. That 1-inch and the 2-inch void cells, it's like it's little. It's under like, I want to quote prices, but they're extremely, extremely affordable. It's just recycled plastic. Same thing, this was a rooftop garden in Sydney, Australia. That system right there, there's no irrigation to it. Whenever you use it for turf or any other type of planting material, you're creating a void space and a constant source of air for the root system. So when you do this kind of stuff, your vegetation goes absolutely nuts. Permeable parking, right? This is a really, really big deal. Everybody's trying to figure out, okay, so we have all this stormwater that's getting ruined by asphalt, and we need to get that water underground right now. What's the best way to do that? Permeable pavers, permeable asphalt, concrete, all of these things have really become a big play in the marketplace. The problem with it is on just about every other design, there's anywhere from 18 inches to 2 feet of gravel beneath those permeable parkers to create enough void space to manage the water. Well, if you use a true void space, all of that aggregate goes away. So that goes to that. Amazing, right? At the end of the day, it's just a wiser use of void space. We're no longer dependent upon aggregate for our stormwater management. We have products that will actively do it itself. Same thing with retaining walls, right? If you have a retaining wall, and this has been a problem forever, if you have a retaining wall, you waterproof it. Right now, one of the big solutions is a dimpled product, right? And what they're trying to do is create a void space. Ours is truly a void space. That will never, ever go away. Waterproof liner, void space, geotextile. That's it. It's guaranteed you'll never have problems draining that retaining wall again. From an engineering perspective, this is unheard of in the marketplace. You wouldn't think so, but it is, because we've done things the same way for so long. People just don't understand or expect that there's a better way to do it, and ultimately there is. Understand, right, when I get up here and I criticize us for saying we did a good job of screwing things up, I'm correct. We did. And so did the people before us and the people before them. Did we try to screw it up? No, not at all. But here's the thing, right? If you understand that you've been designing things the same way that has caused the problems that I showed you, and then I just showed you another way to design things that captures real estate, lowers cost, improves design capabilities, why would you continue to do things the same way? I was serious when I was talking about my kids. I'm dead serious. This is why I do what I do. If you guys don't believe we're in a problem, go get my book. It's bad. It's really, really bad. Our Walmart guy would concur with me. I'm guessing. Yes? Yes. Go out and take a look at it. It's on us, right? This is why I love what I do. I sleep great at night. Because I know 30 years from now, when one of my sons comes up and says, Dad, what happened? I say, Son, I did everything I could. If you're an engineer or a design professional and you understand there are better ways to design things for the future, how can you ignore that? You, as design professionals, must accept the responsibility for our future. You're designing it, as am I. You have to serve the people, period. If you're able to serve the client during that process to a better degree than they were served before, you're doing your job. Not to mention that as a design professional, if you're able to take more innovative and more cost-effective solutions to your client than your competitor, does this give you an advantage? Yes. This is something that we understood in the building environment 15 years ago. We realized that the first people to lock on to this whole water thing would do really good. The reason that the development that had the rain harvesting systems, right, the master plan community that we did, the reason that was done in the first place, the development had a terrible public image in Santa Fe, New Mexico. So they stepped up and said, you know what, we need to do something better with water. It was originally it was a PR strategy to help improve public image of the development. It worked. They had people lined up out the door after they started doing it, and they made the cover of Builder magazine. The PR that they got out of it was unbelievable. Not to mention that we did things that really, really served the purpose as well. So there's so many other advantages to understanding there are better ways to do things, guys. You can keep doing it the way it's been done for 50 years. And many of you will, and that's just the way it is. If you want to do your job good, better than your competitors, and you want to do something for your kids or your grandkids, I encourage you to start thinking about different ways to do your job. And that's it. Any questions? Yes?
Just curious, if you do a permeable paper insulation over the boxes, what do you use?
You can.
Like a setting bed and an edge restraint?
Just any type of free drain material. It really depends on the region and what aggregate material's available, but as long as it's a compactable free drain material, then we're fine. Same thing with the outside of the boxes when we do like large infiltration systems. Like there's no gravel in the middle of it. Around the edges there are, just to keep the system compacted in, you know, so the whole thing gets wrapped in geotextile and we'll compact around those edges, but that's it. Same thing on top. And so we can control that profile. We can say there's 6 inches of sand on above the boxes and then the surfaces. Or if those boxes need to be down 5 feet and we need to figure out a way to use free drain material to get that down. It just depends on the profile of the job. You know what I mean? But it's limitless in your capabilities and options.
So it basically just replaces the base detail and then everything above that should be...
Yep, for most. And if you're going to be driving over the boxes, we need at least 3 feet of cover over the boxes, right, to make sure there's enough structural capability. Yes?
How are the underground chambers cleaned out? That's the biggest challenge that we have with underground systems is ongoing maintenance. So how do you access this to clean them?
Okay. There. How do you clean this, right? This question?
Yes.
Okay. First, put clean water in. If you put clean water in it, you don't have to clean it out. But if that is not possible, right? You can have a PVC standpipe that comes in the system on one side, another PVC standpipe that comes in the system on the other. You flush with one, you suck out with the other. It's easy. The sediment just gets stirred up and you suck it out. Really, really easy. Also, engineers want to inspect our systems, right? Which is great. We have panels inside these boxes that we can use that create a pathway all the way through it. So if you wanted to send a camera down to inspect the entire system, you can. It's just a matter of using one panel over another. Any other questions? Yes?
Have you looked at the effects of frost?
Yeah. Yeah. Ultimately, you want to get your water management below frost line, and then it's a non-issue. Again, that gets really challenging up here in the Northeast because your water tables are so high, right, and your frost line is so deep. That's where if we have a profile of a stormwater management system that's only 18 inches tall, regardless of where that's at, right, that's a fantastic depth to stay above a water table yet below a frost line. If we need to get really creative, and let's say you only have this much space below your frost line and above a water table, we can use those drainage cells. Ideally, that's what you want to do.
So you're saying that these boxes need to be below the frost line then?
They don't have to be, but it's a good idea. And it comes down to your stormwater calcs, really. You want the majority of the water below the frost line. So if you have a depth of boxes that say 6 feet, does that entire 6 feet need to be below frost line? No. Again, it just comes down to the site. Yes?
I just want to make sure I heard you clearly. You said minimum cover of 3 feet over the boxes.
When it's an H25 load rated application. So if you're driving a concrete truck over it or a fire truck, yes.
What about soluble materials like salt?
I'm sorry?
What about soluble materials like road salt?
Road salts. Again, this is where that comes in, right? You want to flush out as much as you can. With it being recycled plastic, we haven't seen any degradation from salts. That's a great question. I'll ask the owner on that. Leave me your card and I'll get back to you. Anyone else? Yes?
We install a lot of rain gardens and also put in some of the chamber systems. But usually what the engineers and the architects tell me is that the reason we're doing more rain gardens is purely cost. They say that the chamber system is a lot more money.
And again, it comes down to money, right? That's why I said it at the beginning. And that's a terrible answer, but it's really the truth. Because you guys have to understand the entire process, right? From the owner's perspective, they're trying to build whatever it is they're trying to build. It doesn't matter if it's a city or a developer. They have a certain amount of money for that project, and they want to make that money go as far as they can, period. They will do whatever they can to save money. It comes down to money. So in order for you to be innovative, you still have to be really, really cost effective. Because our holes are so much smaller and because there's so much less backfill, that frees up a ton of money to go do whatever you want to with. But yeah, it comes down to money. And same thing in California. Rain gardens are getting huge. Bioswales are huge. Engineered soils that clean water, huge. Because California's, man, they're huge problems. Anyone else? Yes?
So the 3 feet that you're talking about underneath the pavement, above these boxes, I'm trying to understand that structural coefficient in the cross section that we're looking at here. You're not really giving any structural capacity to these boxes to support the wheel loads, and that's why you need the 3 feet of gravel above these boxes so that by the time that influence zone hits the boxes, it's minimized.
It's minimized, yeah, and it's dispersed. Yeah. Anyone else? Yes?
Well, there's the question before about maintenance and cleaning it out, and you mentioned that having a filtration system on the front end to put in more clean water or clean water to begin with will help that. What's the maintenance schedule and the procedure like on those front end filtration systems?
And man, that changes from city to city because in some cities they have more trees. You know what I mean? Or there's more dust, for example, in Las Vegas, Nevada. So really just comes down to understanding from a municipal perspective, how often do these things need to be cleaned out? Normally like every 6 months to a year. And they're really simple. It's a basket filter, like a swimming pool. You take the top off, you pull the basket out, shake it, and set it back in. That's it. But again, that's totally related to where it's at. Anyone else? No? Thank you guys so much for your time. I appreciate it. Have a great day.